Physicist, a science podcast in English by the grade 11 students of Notre Dame de Sion.
Hello again, and welcome to a new episode of Physics Bits, where two of our grade 11 students are going to be talking to us about one of the famous figures in the history of science. Today's scientific figure is Albert Einstein, so somebody who's quite well known, and we have two new students. Do you guys want to present yourselves?
Hello, I'm Camille.
So we have Camille and...
Hello, I'm Pierre.
And Pierre, who did a really good job on Einstein, trying to give us a bit of his life story and also talking about some of his theories. It's going to be a bit more difficult, I think, to talk about his theories without a blackboard, but I'm sure you guys are going to give it a good shot. So, how about we start with one of you guys starting to talk to us about the life of Einstein, maybe the main points in it, what he did, stuff like that. So, Camille, It looks like you're going to start.
Yes. He was born in 1879 in Ulm, Germany, and he died in the USA in 1959. When he was 1 year old, his family moved to Munich, and he went to school there. He didn't like it very much, but he was very good at math.
Mm-hmm.
He learned calculus on his own when he was 12. And then he tried to get in Polytechnic in Munich. He failed the first time, but he got in the second time. And he married one of his classmates, Mileva Marik, in 1903. He started working as a patent clerk, where he worked on different theories. In 1905, he published 4 very important articles about different topics like relativity and the photoelectric effect, and he won the Nobel Prize for it.
Many years later.
Yes.
Right. In 1905 he published, and his Nobel Prize is about 20 years later in 1921.
And then he worked as a professor in different universities in Europe, and then he left Europe in 1933 because of anti-Semitism.
Right.
And he worked at Princeton University, and he died there.
Right.
And
so he spent the last 20 years of his life in the US,
yes.
Where he was very well known. He was a superstar.
Yes.
And his death was on every paper, very well known.
And also, because he was so famous, his brain was stolen by Thomas Harvey.
Yeah.
And so he did some research in it, and he found out that there was a lot of glial cells, and which improved the
right.
intelligence somehow, and his logic thinking area was bigger than usual, but it's not a...
Right, I'm sure there are many smart people and scientists who have
they wanted
special
to know
brains.
why he was so...
Right, but that's another one of those well-known stories that his brain was kept after his death to be studied to see what made him so clever. So Pierre, can you talk to us a little bit about what you talked about during the presentation to the class?
Yeah, he developed many theories as the theory of relativity and the general relativity.
So can you maybe start by telling us what 1905 is that famous year where he published 3 very groundbreaking papers. Do you remember what the 3 articles that he published were on, or no?
About the photoelectric effect.
Right, so one of them, which was the one that actually won him the Nobel Prize, was about the photoelectric effect, which explains how basically photosensitive certain metals react. They produce electricity when there's light hitting it. The other 2, do you remember? Well, one of them,
it was about relativity.
Right, what we call today special relativity, relativité restreinte in French, which 10 years later kind of evolved into what we call general relativity. And do you guys know what the 3rd paper was?
No.
So it was a paper he published trying to explain a phenomenon called Brownian motion.
Oh, yes.
And Brownian motion, do you know what it is, Camille?
No, I just...
You'd come across it. So Brownian motion basically was something that was discovered by a guy named Mr. Brown in the 19th century, I believe, where when you could look under a microscope at a particle of soot, so ash or smoke, a particle of a liquid, when you look at it, the movement is very arbitrary. So it keeps like vibrating and then going in some place and then somewhere else, and there was no explanation for it, right? Einstein was the one who came up with the explanation, giving that saying that basically there are invisible particles, what we call molecules basically, right? Something that we knew about in chemistry, that are hitting it from every side with lots of different energies, and all of this gives a very sort of arbitrary and very what we call stochastic motion, and this was an explanation. So what is interesting is that 2 of his 3 papers were very much focused on the scale of matter, which is at the atomic scale and the scale of small stuff. But he's very well known in this year for the paper on relativity. So, Pierre, do you want to talk to us a little bit about what this special relativity was? Why is it so special?
Yeah, basically special relativity, it's like it's between time and space, because if you if you put on a graph and the motion of something, and you keep something straight, like you for each time something at the same position.
Mm-hmm.
If you move the graph to give another character, it is the resting state, it wouldn't be it would change. So
I know it's very difficult to talk about it without a graph,
Yeah.
but so I think the starting point was good. It talks about space and it talks about time, right? So what is the most essential thing that Einstein is saying with relativity about space and time? What is it about, this theory?
it's about each particular point of view.
Regarding the motion of
Yeah.
something, right? So the idea of relativity, we actually have it for many hundreds of years. Galileo talked about relativity. Newton talked about relativity. And so Einstein is not creating anything new here. What is new in Einstein's way of looking at motion and movement? What are the origins of this theory? Do you remember or no?
Truly, no.
No? Okay. It's okay. It's pretty advanced stuff and we haven't really looked at it. So the basic idea being that every movement depends on the choice of your frame of reference, what we've taught you guys to be called référentiel in French, except for light. And light has very special characteristics. It has very special behavior. And the special behavior is that light always has the same speed regardless of what frame of reference. This is not true for anything else. If you're going in a car at 50 kilometers an hour and you throw a ball backwards 50 kilometers an hour, somebody who's on the side of the road will see the ball not move at all. Right? It'll just do a vertical motion. Well, with light, that doesn't work. With light, regardless of who's looking at it, basically they get the same result. And so Einstein, which had seen this result from the end of the 20th century, was trying to figure out a way of explaining why such a thing is even possible. And his idea was to talk about, well, basically everything that we use to measure, distance, time, etc., uses light as sort of the starting point. And that's how we got a lot of these special results. So did you guys want to talk a little bit maybe about what are some of the specific points of relativity which are interesting? You guys, I remember briefly mentioned that in your presentation.
Yeah, there's the fact, the mass energy equivalence.
Right, the famous equation, maybe the
the
most well-known equation, which
E
is...
equals mc squared.
Yeah.
So it actually it's in the relativity, because when you see a star at night,
Mm-hmm.
it's actually not in the same position as it's exactly is, because because of the equation E equal mc squared, we know that energy is also a mass. So in the and because we know light is made of energy, it's attracted by gravity like any object, and so when you see a star, maybe it's not where it's supposed
So basically what
to
you're
be.
saying is that when light comes from the stars and when it passes near a star, this light is going to be bent. It's going to change its direction, right?
Yeah.
So what we see is not light traveling necessarily in a straight line. Sometimes it's bent, so we get the impression it's in one place, whereas in reality it's slightly over to one side or another. Well, this is what we call gravitational lensing. So what else is there in relativity that you guys found which was interesting, revolutionary? Camille?
I don't really know about relativity, but I think the photoelectric
Right,
effect
so let's talk
was
about photoelectric effect, yeah.
interesting. So it existed, it was discovered before Einstein.
Mhm.
It was the fact that when a light hits metal,
certain metals or what we call mixes of metals,
it releases electrons.
Right.
And it creates electricity.
Right. So electrons not only are they released, but they can start flowing, and that's what a current is. Okay.
And but no one understood why it worked with some wavelengths and some
not with others.
It didn't work. And so Einstein had a theory that light was made with particles, which are photons, and they cannot be divided. And he used that, and he created a new equation to explain the photoelectric effect.
Right.
And it works because some photons have enough energy to push the electrons, and that's why it works.
Right. So he didn't discover the photoelectric effect. This was already known. He explained it, and his explanation used the idea of particles of light and going back to the electronic structure of matter, which at that time was kind of new, right? This is right at the beginning of quantum mechanics. So it kind of reinforced this idea that there's something really strange and interesting going on at this scale, which was not the case. So it's interesting because if we look at it historically, the first person to talk about light as made up of particles was Isaac Newton. And so he, in a way, comes back to some idea that comes from Newton, and he sort of supports this idea. Whereas relativity is also talking about mechanics, but is showing everything that mechanics of Newton was not able to show. So there's something interesting historically going on over there. I'm curious, did you guys find any interesting facts about Einstein? Well, there's so much stories about Einstein, and there's pictures of him eating ice cream and sticking his tongue out, and he's more than just a scientific characteristic. He's like a pop culture figure, right? He's like an icon, and there's lots of mythology around him. Did you guys find anything interesting, or did you find some stuff that kind of contradicts a lot of the mythology around Einstein? I
don't know about contradictions, but he wrote a letter about the Manhattan Project.
Right, so he was one of the moving forces to get Manhattan. Can you remind us what the Manhattan Project was?
It was about the atomic bomb.
Right, this was the project that created the atomic bomb in the late 1930s and early 1940s. And so his letter what was it about?
He encouraged it at first, but then he later after the bomb was created, he said he regretted it because it was
such a devastating force, right? So many of the scientists who were working on that project, once they saw what it has actually done in Japan, they had a lot of regret. Robert Oppenheimer, who was the chief scientist on the project, had the famous sentence, "I've become death." And so he wrote this letter to whom? Do you remember?
So it was everybody. I don't know.
No, it was to one person who has a lot of power. Who has the most power in the US? Right, it was President Roosevelt at the time, to convince him. He wasn't the only one, but he was the most famous scientist to sign the letter to sort of convince him to do it. So did you guys find out there's also this story that Einstein was a really bad math student. He was generally a bad student, or he was bad in math and he failed. Did you guys find anything on that? Is that true?
No, it's not true.
No.
A lot of websites actually say that it was just dumb luck what he did, but a lot of criticism. But anyone who's ever achieved something in life is criticized of something.
Having some luck to do with it.
Yeah, so there's no actual proof of that he was bad.
So I don't think you can just by dumb luck, as you say, come upon like 3 brilliant ideas, one of them that wins a Nobel Prize and the other one revolutionizes all of science.
He had just a problem with authority. He was fired because he had bad behavior.
Did he have bad behavior?
Yeah.
What kind of bad behavior what did you find?
I don't know. He just said he didn't respect his teacher.
So I think what happened is that he was somebody who had a lot of interesting ideas in his head. He had a lot of really interesting questions in his head. And he wasn't somebody who was necessarily very concerned with having like excellent marks and being first in his class, which doesn't mean that you're not good. It just means you have other preoccupations, right? Yeah. It's true that he wasn't brilliant in school. He didn't have excellent marks. He didn't fail. He wasn't like a bad student. He just, I guess. It is interesting that I think there is a story, and I think there's some truth to it, that one of his math teachers, Hermann Minkowski, who later was very involved in relativity, I think at one point maybe said something like, he's never going to amount to much. And he did amount to more than some. thing. And Minkowski was one of the first mathematicians to take up his theory and reformulate it in a very beautiful way. And we talk about Minkowski metric and the Minkowski representation. So in that sense, it's good because a lot of the great scientists that we've seen, they were brilliant students, right, as well. Einstein, I think, was a pretty good student. Just maybe he wasn't always concerned with being number one, right? So, did you guys find anything else interesting, or have we covered most of it?
There's actually the fact that he was not only about physics. He always he's also a philosopher, and he wrote many. He always talked about other. He wrote a letter to his daughter when she turns 18 about love or something like that. He told her that achieving something great isn't what's important. And,
it's not the most important thing.
It's not the
I wonder if with Einstein, just because he was such a cultural figure, we just know more about the stuff that wasn't scientific, whereas I'm sure every scientist who had a child probably at some point wrote a letter or said something to him. It's just that it doesn't enter into the pop culture imagination the way with Einstein it did. All right. Well, thank you very much to Camille and Pierre. That was a really interesting presentation on an interesting figure in the history of science. Great, and we'll see you next time with another episode of Physics Bits.